Hi, everyone. So, I want to take a look at something that you might or might not even need this video for. There's some common sense here, and there's some use of units. And if you're good in say, a physical science class, you might already be good with units and thinking about what things represent. But we've spent so long finding derivatives that equal dy over dx that sometimes people forget that these functions might represent something. Here's one example. Take a look at the problem that's in front of you. It's about a city and the population basically throughout the 80s and 90s. All we're going to do is stop and evaluate things that have already been told to us in the actual problem. For example, in part A, all I'm asking for, what are the units there? So in other words, those units have to be representing something. When I take a look at that up here, I see f of 8. What's the 8 represent? As a matter of fact, what does the 158 represent? Well, if you look up here originally, this is supposedly the population function, and t represents time. You have to be really specific. Population is in thousands of people, and t is in the years since 1980. So what are the units of 8? Well, technically the units of 8 are years, but you want to be even more specific. Years since 1980. And as a matter of fact, when we stop and think that f of t equals, well, some kind of number here, it represents like a population. That means that 158 is actually representing the population. So basically, 8 years after 1980, there were 158,000 people. So then we get to part B and we have to think, well, what does this mean? Well, I think I just said it. What's the meaning of that statement? That means 8 years after 1980, the population was 158,000 people. I don't know why I'm writing this down. I just said it out loud, but that's something to think about. What does that statement mean? This is just functions. This is not even derivatives yet. But I tell you what, let's get to the derivatives. Part C. Now we're saying what happens if you take the derivative of f at 8 and it equals 2.5. Well, you have to realize if I take the derivative of this function, t is still going to represent the number of years. So that's still going to be 8 years after 1980. So that hasn't changed. But what does the derivative represent? In this case, it's a function of population as the time changes. And so when we asked what's the meaning of that, it's really going to be in thousands of people per year. You're looking at that change, and we're seeing how many thousands of people per year. And the fact that it is 2.5 here, the fact that it's asking about the number of years there, well, that's a good indicator that in 1988, the population was growing basically 2,500 people per year. Oops. People per year. I tried to make 2,500 people. The people ended up being a zero, but I think I fixed that. When you're looking at a derivative, it's not just dy over dx. It could be whatever variables are in that problem. And then finally, let's get to E. What's the sign of the derivative at 1? Well, if you happen to see this at 1, we're talking about the year 1981. Was the change in the population positive or negative?